In this example, we are going to create a logical architecture for our Vista system. Right here you can see the BDD, where we have our Vista as the top block. It's decomposed into the processor, the push-to-talk, the headset, the battery, the transceiver, and the processor is further decomposed into an onboard data repository and a question answerer. We've already started to build the IBD for the Vista system. So if I double click, you can see that we have the blocks, the battery, the push-to-talk, the headset, the processor, and the transceiver. The first thing we're going to do is add some proxy ports to each of our devices. So I'm going to click on proxy port, hold down shift, and I'm going to add 4 proxy ports to my battery. I'm going to add 2 to my push-to-talk, 3 to my headset, 3 for my processor, and 2 for my transceiver. And escape. Next thing I'm going to do is I'm going to name my proxy ports. And to do that, what I'm going to do is I'm going to name them based off where they are and where they're going to. So this first one, P1 on battery, is going to go from the battery to the push-to-talk. Second one's going to go from the battery to the headset. Third one's going to go from the battery to the processor. Fourth one's going to go battery, transceiver. Now P1 right here is going to be on push-to-talk, is going to connect to the battery, headset, battery, processor, battery, transceiver, battery. Similarly, this port right here is going to connect the push-to-talk to the headset. This one's going to connect the headset to the push-to-talk. This is going to connect the headset to the processor, processor to the headset, processor to the transceiver, transceiver to the processor. The next thing I'm going to do is I'm going to go ahead and run connections between each port. So again, I'm holding down shift while I do this. I don't have to keep reselecting connector from the menu on the side. Next thing I'm going to do is do a quick diagram layout. And we now have our logical IBD, where we have our connections between our logical connections between all of our different subsystems. With the IBD now complete, what we can do is we can define operating states for each of our subsystems. We'll start at the simple part where they're each off or in a standby mode. So the battery is going to be off or on. It doesn't really have a standby. So to do that, I'm going to right click on the battery, click create diagram, state machine diagram. And I'm going to add 2 states for the battery, off and on. And of course, it can go from being off to on and on back to being off. What I'm going to use to trigger that movement is a couple of signals. So I'm going to go back into my containment tree, go down to my value types, and define a few signals. I'm going to create an element, signal. First one's going to be called battery on. Second one, battery off. So when my battery receives the signal battery on, it transitions from off to on. And I just drag it and put it over the transition arrow. And when it's on, if it receives signal battery off, it then transitions to being off. And I can see if I click on the guards, you can now see it's a signal event, battery off, handles all that. And do quick diagram layout. When I turn on my battery, what I want to do is I want it to send that battery on signal to each of the 4 other subsystems. So what I can do is create an activity diagram, an entry activity diagram. I'm going to call it activate system. We hit enter and we hit close. Now you can see it's right here, populates in the window or in the state. So I'm just going to double click on it, and I now have my activity diagram that I can build out. I'm going to start out with an initial node, and what I'm going to do is I'm going to have it send that battery on message 4 times. I'm just going to drag that message over here. And then I'm going to finish my flow, or finish the activity. Let's go and connect them. However, because my battery has 4 ports, I have to define which of the ports I am sending it on, each of these signals on. So I'm saying battery on port. And this first one's going to be on BPTT. So it goes to the point to talk or push to talk. Second one's going to go to the headset. Third one, processor. Fourth one, transceiver. Okay. I'm going to have it send a similar set of messages whenever the battery turns off. I'm just going to set that as being an exit activity. And I'll just call that shutdown system. Create an activity diagram. And it's just going to send the battery off message to each of my 4 subsystems. I'm just going to do the same thing as before, but sending that separate message. And wrapping this up to the transceiver. Okay, I can hit this back arrow now. It takes me back to my state machine, and it now, if I hit it back again, it takes me back to my IBD. So I can add my state machine diagram to this plot by just selecting it from my menu over here and dragging it into the pane. You can see it shows up like that. What I'm going to do is now change it to that icon, and you can see my state machine diagram. So next thing I'm going to do is I'm going to create state machine diagrams for my push to talk, my headset, my processor, and my transceiver, and they're all going to be fairly identical. So create diagram, state machine diagram, and I'm just going to create 2 states, off and standby. The transition from off to standby is going to be battery on, and the transition back is going to be battery off. Do quick diagram layout. And I'm going to do the same for the push to, or for the headset. Off, standby. My 2 transitions. Battery on, battery off. Okay, 2 more to go. And on to the last one. So the next thing I'm going to do is I'm going to add in the state machines for all four of my other subsystems. Let's just move this a little bit to create a little more space. And so I have my headset state machine right here. And my push to talk state machine right there. I have my processor state machine diagram right here. And my transceiver state machine diagram right here. And let's just all right. So I have all my state machine diagrams. I'm just going to have these line up a little bit better with each of my state machine diagrams. I'm going to save it. And the next thing I'm going to do is I'm going to run a simulation. So simulation, run. When I hit play, it's now starting to execute. All my state machine diagrams are currently on off. So if on my battery, I send a message, battery on, you can see it's sending the message now to each of my subsystems and transitions them all to standby. Now, if I send a message from the simulation pane, battery off, it now sends that battery off message to each of my other 4 subsystems, and now everything is turned off. So this is a very simple example of using simulation to show the logical flow. In this case, we're just showing the battery turning on and off all of these subsystems. While that's useful in everything, what we really want to do is show more of the interactions between our subsystems, like how does the push-to-talk interface with the headset, with the processor, the transceiver, and how all of that connects with each other. So the next thing we're going to do is we're going to start adding in the other operating states. So right now we can see our push-to-talk is on off and standby. We're going to add a on state as well. And it's going to transition to the on state when it receives a message push, and it's going to transition back into standby when it receives a message release. So I'm going to go ahead and add those signals. Quick diagram layout just to make this look decent. And when my push to talk is on, I have an entry activity where it's basically telling my system to start recording. I'm also going to create a exit activity so that when it receives the release signal, there's an activity called stop recording. Since everything is being done through my headset, it's sending these commands to my headset to tell it to start recording and then to stop recording. So what we're going to do is we're going to create a signal that goes from our push to talk to our headset that says start recording whenever that push command is given. And then when we release the push to talk, we then send a stop recording message to the headset. So I'm going to create two signals, create element, signal. It's going to be start recording, stop recording. And I'm going to now define my two activity diagrams, start recording and stop recording right there. So I can just find those in my containment tree if I wanted, or I could just double click in my state machine diagram. So start recording is basically going to be as simple as just sending a signal. And we're going to send it over port from the push to talk to the headset. Similarly, stop recording. The stop recording activity is going to be sending that stop recording message over the same port. All right. So now what we can see, if I run my simulation, I'm going to turn my battery on. Everything's in standby. When I go to my push to talk and I send it that push command, it sends a message to my headset telling it to start recording. When I send the release command, it sends a message saying to stop recording. All right, so now what we can do is we can go to the next part, the headset, and start saying, okay, what do we need to do with the headset? So I'm going to stop the simulation. And for the headset, we have two general states. In addition to off and standby, we have recording, which is the one that we're concerned with now. And we also are going to have a playback or playing state. That's going to be related to when we're playing the answers to our questions. So it's going to move from standby to recording when we receive that start recording command. It's going to move back to standby when we receive that stop recording command. I'm going to have two activities on here. So I'm going to have an entry activity that's going to be called start recording audio, and then exit that says send recorded audio. I'm going to hold off on my playing state for now. And I'm going to define my start recording audio and send recording audio. So start recording audio is going to be a very simple activity diagram. Just going to read it. It's basically just saying to record audio. So my system, it needs to record audio. When I send the recording now, all I'm going to do is I'm going to send another signal called recording. And this is the voice recording. I'm going to send it to my processor. All right, let's do a quick diagram layout. playing is down here on its own for the time being. We'll mess with that later. All right, so the next thing we're going to do is we're going to handle, next thing we're going to do is we're going to create the activity diagram for our processor. So our processor will have one other state, which is processing signal. And it's going to be triggered off getting that recording. Once a response is generated, it's going that there'll be another message called response generated. They'll tell the processor that it's all good and can go back into standby. My processing signal is going to have one activity diagram. It's going to be entry, so when it enters that state, it automatically starts executing this. I'm going to call this activity diagram process signal. All right, so my process signal activity is going to start out. I'm going to convert audio signal to query. I'm going to query the database to see if the answer is in the onboard database. And then if it's in the database, I'm going to continue. So if it's in the database, you'll understand these join and merges in a second. I'm going to continue, and I'm going to send a message. I need to add a new message type. So let's create element, signal. I'm going to call this response to query. I'm going to send that over to my headset. And then I'm going to send an internal message to my in this system saying that a response has been generated, and that allows me to change my state back. However, now what happens if the query is not in the database? What I'm going to do then is I'm going to send a message to my transceiver. So I'm going to create another signal. I'm going to call it data out. And it's going to go over my port from my processor to my transceiver. And then once it responds back, I am going to receive another message. I'm going to call this data in. Actually, sorry. I need to define a new signal, create element, signal, data in. Tie it to that. And once I receive the data response from my transceiver, it comes back into that join. So next I need to set the guards on when it needs to go send it out to the transceiver versus processing internally. So I double click, type guard, and I'm going to set this one to being else, and this one as being is query in database. So let's do a quick diagram layout so this looks decent. All right, so basically it converts audio signal to a query. It queries the database. If query is in database, so if it's yes, it continues on, and it sends a response to the headset and sends an internal message to the processor to itself saying that response has been generated. If not, it sends a data message out to the transceiver. It then waits until it receives a message back and then proceeds to execute everything else. All right, so we now have the processor done. All we have to do now is the transceiver. Gonna hit save. And now let's create the block for the transceiver. So I'm going to add another state on here. It's called query online database. It's going to move into that anytime when I get the data out message from my processor. And it's going to move back to standby whenever it gets the message transmission complete. Transmission complete. All right. So when I query my online database, I'm going to create a entry activity. And I'm going to name it query online database. Just make it one word. Hit close. Double click on it. And now I'm going to define my activity diagram, which is going to start encrypt data. Transmit data to cloud. Receive response. Now I'm going to send the message in the form of data in. I'm going to send that over the port TP. And then I'm going to send an internal message to myself or to the transceiver saying transmission is complete, so I know to go back to standby. So let's close that out. Let's connect things. All right. So we now have our transceiver belt built. So going back to my diagram and everything. So we can see kind of the general structure. However, one thing I need to do now is I need to go back to my headset for a second because I do have to, when I receive that message and it when the processor sends a recording back when it sends a response to the query back to the headset, it needs to move into the playing mode. So let's go ahead and create that transition, response to query, transitions that. And then I'm going to create another signal. I'm going to call it playback complete. Oh, sorry, signal. A little ahead of myself. Playback complete. I'm going to use that to transition from playing back to standby. When I'm playing, I'm going to have one activity. It's going to be called play response. Close. If I open that activity diagram, it's going to have our initial node. I'm going to be playing the audio signal. And then I'm going to send an internal message saying playback complete to my headset. That tells it to go back to standby. And then I might close my activity final. Close that. Layout, quick diagram layout. And actually, let's make this nicer as well. Let's do quick diagram layout as well here. Let's see if this works. Save. Let's simulate. All right, so I started the simulation. You can see everything is off. So now I'm going to go to my battery, turn the battery on, and you can see everything is now moved into standby mode. So I'm going to go to my push to talk. I'm going to push. My headset's now in the recording phase. I'm going to release. So it'll happen a little quickly. But right now I'm processing the signal. In my activity diagram for processing signal, set that open a second ago. I should have left it open. You can see that I'm at that decision node. It's asking me if the query is in the database. I'm going to initially say yes. And you can see it follows that path. Now if I go back, everything played back while I was transitioning. And yeah, we're now back in standby mode. So let's do it again. Push, release. So it's query in database. I'm going to go back here. I'm going to hit no. So it sends the data out, data back in, and the message is played, and we're all back in standby. So the general purpose of all of this is just to show the data flow, the logical flow of information as you go through your system and how your system interacts with it, all the different, how your system interacts internally between all of the subsystems.